You've been asking how I like the Bambu Lab X1-Carbon. Okay, let's talk about it. Welcome back to Cloud 42. My name is James, and this is the X1-Carbon 3D printer from Bambu Lab, and so is this. I've been using these printers for about 6 weeks now, and I have about 300 hours on them, so I feel like I understand what they're about and have enough experience with them to share my thoughts. First off though, some disclosures. This printer was provided to me free of charge by Bambu Lab. I agreed to use it and provide feedback, but I'm not required to do a review, and I'm not even required to show it on the channel if I don't want to. However, after using it for a couple of weeks, I purchased a second identical printer with my own money at full retail price. Bambu Lab isn't paying me anything directly to promote their products. However, I am an affiliate, so if you use any of the links down in the video description to buy something, I earn a small percentage at no additional cost to you. Just keep that in mind as you evaluate what I have to say about it. The X1-Carbon is a Core XY 3D printer with a fully enclosed chamber and all the fancy new features that everybody else in the industry is trying to duplicate right now. It has a lightweight carbon fiber gantry to support fast printing and high accelerations. In fact, if you've heard anything about this printer, it's no doubt that it's super fast, and it is very fast. It has a 256 millimeter cube build volume with a 300 degrees Celsius hardened steel nozzle and an all metal hot end. It has a heated bed, and you can get a bunch of different flexible build plates with different surfaces. It has full mesh bed leveling, and it does this by actually probing the bed with the nozzle, so there's no Z offset adjustment required or really even possible. The print head also has a built-in down-facing camera and a dual laser LiDAR system that it can use to read the bed surface and any filament that's laid down on it. And this allows it to do its own flow rate and pressure advance calibration, and it can also scan the first layer for defects after it's laid down. It also uses the down-facing camera to read a QR code on the build plate to ensure that it's positioned correctly and that the build plate that's actually in the printer matches the settings that were used in the slicer software. It has a chamber camera that you can use to monitor the printing process remotely, and that it can also use for AI-based spaghetti failure detection. So if the part pops off the bed and it's just squirting spaghetti all over the place, in theory, it can detect that. Now, I've not been able to test that because I haven't made any spaghetti. None of my parts have come off the bed. The goal with all of these features is to make the printing process as simple as possible and to require as little knowledge and experience from the operator as possible. In theory, the printer takes care of everything. It takes care of purging and cleaning the nozzle, setting the Z height, adjusting flow rates, and checking the first layer for defects, so that the experience of using it is as close to the fictional Star Trek matter replicator as possible. It's certainly not perfect, but they're getting closer. The base X1-Carbon printer retails in the US for about $1,200. Now, both of these printers have the optional 4-spool AMS that can automatically load and swap between different colors and materials during the print. In this configuration, they retail for about $1,450. Let's start out by talking about speed. These are marketed as being extremely fast. They throw around numbers like 500 millimeters per second and 20 meters per second squared acceleration, and okay, I'll accept those numbers. But what does that actually mean? If you print the pre-sliced benchy that comes already loaded on the printer, it's done in 20 minutes, and it is impressive to watch, but it's kind of a party trick, right? It's fun to watch, but not of much practical use. For actual prints of real parts that I want to make using the default profiles in the slicer, it doesn't run quite that fast, but it's still typically about 4 times faster than the same part printed on a Prusa Mark III. A 4-hour print on the Mark III is done in an hour on the Bambu. A 24-hour Prusa print is done in 6. Most of the small prints that I run in the shop take 15 to 20 minutes, and that's the real superpower of this machine. It means that when I'm prototyping and iterating on a design, I can get several design iterations in a day instead of just one or maybe two. I can print earlier in the process, and I can print more often, and I can get feedback on my design sooner, fix problems sooner, and see the results of my changes sooner. If my part's going to take 4 to 6 hours to print, I'll spend a lot of time in the computer trying to make sure everything is right before printing it. I'll send the job to the printer at the end of the day and get the results tomorrow. But if I can print the part in 20 minutes to an hour, it's way less costly to just sketch something up that I think is close and just send it. I'll have the results quickly, I can make adjustments and send it again. Doing that 4 or 5 times in a day makes me way more productive when I'm prototyping. And it's a huge win for production printing too. Previously, I was printing 12 spacers for the electronic lead screw on the chute iFast in a job that took 4 hours. I could run 4 jobs in a day for a total of about 48 parts if I wanted to actually sleep. On the X1-Carbon though, I can print 18 in a job and it's done in 2 hours. So I can get 7 jobs a day for a total of 126 parts. That's 2.5 times more productive just because of the speed. Not to mention that I can get 2 of these for about the same price as the iFast, and together they take up about the same amount of space. Okay, so it's fast, but what's the print quality like? Actually, it's pretty good. This is the built-in benchy that was printed at absolutely insane speeds. I think the whole print was under 20 minutes, and it's good. It's really good. In fact, it's one of the cleanest benchies I've ever printed. This is the infamous clock spring torture toaster printed in Bambu Lab PLA Basic. By the way, I'll put links to all of these models down in the video description. As you can see, this is super clean. Overhangs printed great all the way up to 80 degrees. The clearance test sliders are mostly free. I did have to put some pressure on the 0.3 millimeter and 0.2 millimeter clearance sliders to get them to move, and the 0.1 is stuck. I couldn't get it to free up. The gears and the doors are nice and free, and the toast pops up cleanly. There's basically no stringing at all or any other artifacts that I can see in the print. This is the Maker's Muse puzzle cube. This is printed with 0.12 millimeter layers, and it just turned out beautifully. This model has a lot of really difficult unsupported overhangs, and the X1C handled them beautifully. I left the door open to keep the chamber temperature down, and that worked great. The cooling was totally sufficient to freeze the layers without any curling or sagging. This is the version with the 0.3 millimeter clearances, and honestly, it's a little bit loose. I think the 0.2 millimeter version would probably fit a little bit better. This is one of the brackets for the Prusa Mark III light bar by In 3D Space. I printed these in a variety of different materials and they all turned out fantastic. This one is PLA. The features are all crisp and clean. The overhangs are nice. The surfaces all look fantastic. This one's printed in FlashForge ASA, and it also looks great. The bridging was a little bit less clean than in the PLA, but the finished part still looks really good. And the bridging difficulties could just be the settings. Of course, there's no predefined profile for the FlashForge ASA. I had to set it up myself. It does feel to me like the corners aren't quite as crisp in the ASA, but under a microscope, it still looks pretty clean, so it might just be a surface texture thing. They came out really nice, and they are noticeably lighter and have a little bit more flexibility than the PLA, and that's just the ASA material. I also printed a pair in carbon fiber nylon. These are the ones I'm probably going to use. This is just the Bambu Lab PA high temperature carbon fiber. I just let the printer read the RFID tag in the filament and use the default settings, and as you can see, they also turned out great. I did use a brim for these. I trimmed it off with a Noga deburring tool and smoothed the disturbed edge of the print with a heat gun. I also tried printing some larger models in more difficult materials just to see how well the enclosed chamber works. This is a nose piece for my drill press, and it's printed in eSun ABS. The chamber isn't heated, but it does get up to 45 or 50 degrees Celsius if you keep the door closed, and that's apparently enough to be successful with something this large in ABS. Of course, I've also printed several hundred of these PC board spacers. They were all printed with thick layers and a 0.6 millimeter nozzle. And even though these were printed super fast, 18 pieces in 2 hours, they're all still really clean. Honestly, they're much better than what I was getting from the chute iFast, and those were even printed slower. You've also seen some of these other larger prints in other videos already. This grinding wheel balancer was printed in the PA high temperature carbon fiber, and it just turned out fantastic. You can watch the previous video for the details. This one is PETG, and it's also pretty clean. I also printed one in ASA just to see if I could, and yeah, it worked great. These large parts with solid sides do pull a little. They didn't detach from the bed at all, but the buildup of stresses left the bottom surface just slightly curved. They're totally usable, and without an actively heated chamber, this is still quite impressive, but this is probably about as good as it's going to get on any printer without a heated chamber. The last test part I have here is the clipper ringing tower. I actually printed one on the Prusa Mark III and one on the X1-Carbon to compare. This print has sharp corners that are designed specifically to excite ringing, and I'm seeing essentially none. This was printed in PLA with all the defaults. It took about 30 minutes compared to 2 hours on the Mark III. And honestly, I think the print from the Bambu Lab machine looks better. They say that what they're doing isn't exactly the same as the clipper input shaping, but whatever it is, it's working. There are 2 software applications that come with the printer. Bambu Studio is the desktop slicer software. It's a reskinned fork of Prusa Slicer, and it has a lot of the same controls and options. I've run into a few minor glitches in things like the automatic support generation where it didn't identify something correctly. It was easy to fix using the support painting feature to put the support where I wanted it, so it wasn't a big deal, but it isn't as refined as Prusa Slicer. And the same goes for the printing profiles. They're good and they work. In fact, just about everything you've seen in this video was printed with the default settings. For a beginner, they're going to be way better than you'll probably be able to get on your own. But if you're a longtime Prusa fanboy, you will see little tweaks that you want to make them better. This is especially true if you stray from the 0.4 millimeter nozzle that normally comes with the printer. I did some testing with the 0.6 millimeter nozzle, and the presets for that were missing some things like elephant foot compensation, and I had to adjust some settings to get really good results. One other thing I noticed about the print profiles is that there are some performance differences between the different colors of filaments. The default profile for the Bambu PLA Basic, for example, will allow flow rates above 20 cubic millimeters per second, and this works great with the red. But at the highest speeds, the silver PLA starts to choke. It needs to be run a little bit slower, which you can easily do, but that's something that I noticed that wasn't incorporated into the default profiles. They've integrated the print status and monitoring using the chamber camera directly into the Bambu Studio application, and you can also use it to download time-lapse videos of your prints after they complete. They also provide a mobile application called Bambu Handy that allows you to monitor your prints from your mobile phone. The printer's cloud connected, so you can monitor your prints using either application from anywhere on the internet. Now, some people get kind of nervous about any product that interacts with cloud services, and I get that, but I also see the benefits. Being able to monitor and control your printer from anywhere is something that I use all the time. The cloud service also synchronizes your custom material profiles and settings between different computers and facilitates better customer support. When you file a support ticket with Bambu Lab, you have the option of uploading logs and even recorded video of the failed print jobs with your ticket, so the support people can better see what's happening. You can turn off all the cloud features and run in local network only mode, but you do lose functionality if you do that, most notably the ability to monitor your prints with the chamber camera. It would be nice if that was supported in the local network mode, but there are also technical reasons why it's done that way. Just be aware that that's a trade-off. Prusa has set a real precedent in the 3D printing industry by open sourcing their printers. For many people, this is their default expectation. They expect it both out of a sense of fairness to the contributions of so many people who have made the technology a reality over the years, but also so that they can tinker and improve their own printers and have access to a large aftermarket of mods and accessories. This printer is not that. I won't weigh in on the philosophical arguments, but I will try to describe the value that I think Bambu brings to the table. This printer isn't intended to be an extension of the RepRap movement. It's intended to be a tool. It's a part of a vertically integrated ecosystem. They build and manufacture the printers. They sell them through a limited number of channels. They have their own line of accessories and materials, and they've tested with their printers, and they publish their own control and slicing software already set up with settings for their machines and their materials. They're targeting people who do not want to tinker, but just want a turnkey system that they can buy and use. But it's not a totally walled garden either. If you buy your filament from Bambu Lab, it does come with an RFID tag that the printer can identify. It can set up the printer and select the correct slicing settings, but you can still use your own filament and configure things yourself. It also reads the QR codes off of the bed sheets to make sure the correct sheet is in the printer and it's positioned correctly, but you can still substitute your own and disable or click through the checks. If you look at the prices today, you'll pay about $2 a kilogram of a premium to use the Bambu Lab materials with the RFID tags that the printer can identify. Is that worth it to you? It's worth it to me, especially when I've got 4 rolls of something in the AMS and the printer already knows what it is and keeps it straight for me. I think the people who are concerned the most about the closed nature of the solution are worried that Bambu Lab will use tools like the RFID tags to lock it down in the future after selling lots of printers and locking in their customers. And while that is technically possible, I personally think there's a lot more money to be made by leaving it open, charging a small premium for the convenience of using the in-network materials, and selling in volume to people who just don't want to mess around with their printers. Given that this printer is a semi-closed ecosystem, one thing that really surprised me was the availability and pricing of replacement parts. The full hot end assembly with the hardened nozzle, the ceramic heater, the heat sink, and the fan pre-assembled is $30. If you want to try a different diameter of nozzle, this is definitely the way to go. You can just pop off the magnetic cover, take out 2 screws, undo 3 connectors, and swap it in a couple of minutes. You can get just the bare nozzle and heat break for cheaper, but then you have to transfer the heater over and mess around with thermal paste. A replacement gear-driven extruder is $40, the feed motor assembly for the AMS is $35, and you can even buy the X-axis carbon rod assembly for something like $90. Compared to other printers knocking on the door of the industrial space, that's really refreshing. If you remember the chute X+3 I reviewed recently, they actually had a warning sticker on the printer telling you that the carbon rods can't be replaced at all. Not everything about this printer has been perfect. I have encountered a few issues. The main thing I've struggled with has been bed adhesion. The printer comes with a single bed sheet that has what they call the cool plate on one side and the engineering plate on the other. Both are basically smooth, but the cool plate is meant to be used for PLA at 35 degrees Celsius, and the engineering plate is for ABS, polycarbonate, nylon, and other materials at higher temperatures. I personally have struggled to get PLA to stick reliably to the cool plate. I've messed around with glue sticks and liquid glue, both help, and cleaning the plate with dish soap and alcohol help too. Sometimes things stick great, and sometimes they don't. Personally, my advice would be to just skip the cool plate and get the optional textured PEI plate. I've been using it for everything and it has been fantastic. There is also a satin finish plate with a smoother surface that's specifically for PLA. It's in an open beta at the moment and should be available soon, and it is absolutely fantastic. Every first layer I've laid down on it has been essentially perfect. In fact, I don't think I have had a first layer adhesion failure since I stopped trying to use the cool plate. And I've got 300 hours on these machines. That's like 1,200 in Prusa Mark III hours. You may have seen some discussions online about the beds on the Bambu Lab printers not being flat, and it's true, they aren't. At least they aren't as flat as the one on my Prusa Mark III. I initially thought the bed adhesion issues I was having might be related to bed leveling, so I made a tool for measuring the bed shape, and it does have a measurable sag in the center of the front of the bed. It's flatter towards the back on both of my printers, and this appears to be common. Here's a map that someone on Reddit managed to extract from their printer, and this is almost exactly the same shape that I see in the beds on both of my machines. I filed a support ticket, uploaded the logs from the printers, and support sent me new beds for both of them. Now the bed replacement procedure is a little time consuming, so I measured the new beds to see if they're actually better, and they are a little, but they're still pretty similar to the ones that I have. So is this a problem? I think for most of what I print, it isn't. The mesh bed leveling compensates, so the first layer follows the curve of the bed and lays down great. Technically, it does mean that the bottom of a large printed object is not going to be perfectly flat, but I haven't actually noticed this. Most of the things that come off the machine sit flat on a surface plate and are at least as flat as anything I've ever printed on any of my other machines. Now, when a large part does have a little bit of a rock on the surface plate, it's usually because it's a material that shrinks, like ABS, and the out of flat condition is due to stresses in the material and not the shape of the bed. So I think this is just the way it is, and honestly, it hasn't caused me any issues with real parts. So what other things do you want to know about the machine? You no doubt heard other reviewers talk about the poop chute in the back, where the printer discards the excess filament when it purges the nozzle at the start of every print and when it changes filaments during a print. You'll definitely want to put a container back there or print one of the ones available online. For most normal printing, I haven't found it to be excessive. This, in fact, is all of the purge material from my 300 hours of testing. If you are printing large multicolor models, you will generate a lot more, but I don't generally do that. Now, the sound level from the printer is a bit of a mixed bag. When it isn't printing, it's silent. It doesn't have any fans running continuously, which is a really nice change from the chute machines that just whine all the time. But when it is printing, it can generate a fair bit of noise due to the high accelerations. And if you're printing PLA, it turns on the chamber fan up on high, and it makes a surprising amount of noise. It doesn't bother me that much since I'm barely human, but I think most people will want to be in a different room when it's printing. So what's the verdict? Should you buy the Bambu Lab X1-Carbon? I don't know, because I don't know what your needs are. Hopefully I have provided some useful information that you can use to decide if it's right for you. For me, I've already made my choice. Bambu Lab gave me this one for free, and I bought another one myself, and I would do it again just because of the increased productivity that I get from the shortened cycle times. Now, in addition to the capacity I get from having a second printer, it also allows me to keep 8 spools of filament in the AMS units where they will stay dry and ready to go. I keep ASA, polycarbonate, nylon, and high temperature support material in one, and I keep multiple colors of PLA and low temperature support material in the other. That way I can just slice and send a job, whether I'm in the shop or elsewhere, and the job will be waiting for me on the machine later. Now, I'd like to hear from you. Do you have any experience with these machines? Do you have any useful tips or tricks that you'd like to share? Put them down in the comments so we can all benefit from them. If you enjoyed this video or found it useful, feel free to subscribe and maybe consider supporting the channel over on Patreon. If you're already a patron, thank you. You make it possible for me to do this. Thank you for watching.